Okay, so now I'm going to explain how my codes work. So starting with system active equals false, it's just initializing the system state. So when I turn it into system active equals true, my code would actually start working. And then I display like when I press the red button, it starts the detection, and blue button to stop the program. Next, I set up all my boards and ESP32 with these codes, and then here's the new thing. To create an I2C device object for LMX 9614. It's for the thermometer sensor that I bought, and then it has to use I2C connection to connect it to the M5 core. So to connect this, I'll have to set it to the I2C address for MLX for the thermometer sensor, and the default address is MLX 19614. But if you want to find another like a available address for the I2C address, you will have to use another code, and I will demonstrate it later. And now connect it to the M5 core unit and NeoPixel. Here, creating arrays for plotting is for the plotting thing down there. It's just creating like empty arrays for plotting. And then now here is where my code actually starts. So I set a while loop, while true. I set my red button and blue button to digital pin D14 and 13, and then next is detecting if the red button is pressed or not. If the button is pressed, then it displays system activated, and then if the blue button is pressed, it will just display the program is stopped. So from the system active, if I press red button for system active, it'll jump to this line 46 if system active. Now, these two are the formulas or the formulas to read the temperatures from the thermometer unit, thermometer sensor, and it's just reading the data and then doing some calculation. I searched it up on the internet, and this is the actual equation that people use. Now, it's storing time and temperature data, which is for the plot, and then I'll display the results from reading the temperature. And then the if statement is if the object temperature is above 30 degrees Celsius, I'll write digital pin 26 to 1. It means turning on the water pump. And then write the color to red. So it means that this object, the CPU, is now really hot. Or else I'll just write it to 0. Just turn the pump off and then display it is cold enough, and then the cooling system is off, and then turn it into blue. Next is turning to the plot data. So there are there are from line 70 to line 76 is an actual plot uh, plot program or plot code, and then I add pause 0.5 to prevent the excessive polling, and additional 0.052, and then last, if it jumps out of the while true loop, it'll just display program terminated. Okay, so now I'm going to explain um, how the I2C address works. So first, I clear the ESP32 because I had an issue for putting input again into the Arduino object. So I did this clear ESP32, and then I define my board type, which is found in the beginning. I think it's in some M5 basic course from Professor Kai, and then connected to ESP32, which you find your serial port and board types. So I'm connecting it to I2C address, and then I can scan my I2C address by doing scan I2C bus ESP32. I found this code online to find device address because I can't find my address in the beginning for the thermometer sensor. And then I did display detected I2C device addresses, and then it'll just show a list of the addresses that you can use for I2C device address.